Okay, here's a problem that some of my students had some difficulty with. This is another example where we have to find the surface area of a pyramid, but there's a little bit more to it than that. Okay, so let's take a look at what it's asking for. It says, and before I get started, I do have students present in the classroom, and I appreciate my active listeners who are sitting up. They're wide awake, they're alert, they're listening with purpose. They really want to see how I would approach this item. They have their papers in front of them. They're going to make corrections where necessary. They're going to discover where they strayed from the path that Mr. Hall is going to show. And this is just an exciting time. I can't wait to see how many people really learn from this demonstration. I can almost see the little light bulbs lighting up the whole room. Alright, says, write a numeric expression to represent the surface area of the pyramid. Then we need to tell what is the surface area of the pyramid. Well, let's look at it. We have a rectangular pyramid, and that's important to know. That tells us how many sides this thing has. Because if we have a rectangular pyramid, and I'll tell you what, I'm going to go ahead and make a really neat looking, I'm going to make a much neater looking net than I usually bother to do. So I'm going to go ahead and make a rectangular base. And by the way, by no means is this being drawn to scale. The only purpose of my nets that I draw are to let me see how many sides I'm dealing with and make sure I don't leave anything out. I could really solve this problem without the net, but I just feel comfortable. It just gives me comfort to know I'm going to get it right. And so why not? I have time. It's not like I have to be anywhere in the next 3 or 4 minutes. And but now this were a K-prep item or a testing item, and if I didn't have the time for it, I don't know if I would do the net in that case, but I want to be precise. So I'm going to make my net. So I have a rectangular base, so that tells me I have to have 4 triangles to make up this shape. Now that's important because just looking at this pyramid, I only see this side and this side. It could be that maybe behind these 2 sides unseen is just one more side. But because it's a rectangular pyramid, or the base is a rectangle, we know it has 4 triangles to make it up. So I'm going to go ahead and make up my little triangular sides. And I'm going to, okay, well, let's go like that. But like I said a moment ago, not drawn to scale whatsoever. Not drawn to scale. These are not going to, if I were to cut this net out, it would not actually make, I'm satisfied, a shape that would resemble this pyramid. Alright, now let's talk about our dimensions. One thing I will point out is that this side here is 20 feet, because it's 20 feet there, and this side here is 30 feet, because it's 30 feet there. And because this is a rectangle, opposite sides are congruent. So this is 20 feet, and this is 20 feet, and this is 30 feet, then this is 30 feet. And that's important to know, not just to find the surface area of the base, but also I need to know the base of these triangles in order to find their surface area. And the height, it tells us on this side, these triangles are 16.2 feet high. So the base here, the height is going to be 16.2 feet. And the height here, it shows us, is 11.8 feet. So this is going to be 11.8 feet. So by drawing my net, even though it's not drawn to scale, I can see right off that I have two triangles that are congruent, and I have these 2 triangles that are congruent. And I'm not going to leave anything out when I find these surface areas. So let's go ahead and check it out. Now I need to write a numeric expression first. And the formulas I'm going to be using for this are going to be like area equals base times height to find the area of this rectangle. And then for a triangle, it's area equals half base times height. But since I have two that are congruent, I can just say 2 times half times base times height. I could do it that way or whatever. Anyhow, this would be, I'm going to go ahead and write this out. So 20 by 30, so 20 times 30, I'm going to group that together, plus, and I'm going to say 2 times, well these are both half times the base is 20 times the height 16.2, plus, and now I'm going to get these here, 2 times half times 30 times 11.8, and there you go. So that's my numeric expression, and all I have to do is just finish it out. I just have to finish it out, and I'm going to go ahead and do it right now. This is going to be pretty easy. So 20 times 30 is 600. Now, one of the things I want to say here, anytime you times 2 and a half, 2 times half is going to be 1. 1 is the multiplicative identity. So, because anytime you multiply a number by 1, you get a product that's the number you start out with, these kind of cancel each other out. So I'm just going to scratch them kind of out. I'm going to focus on 20 times 16.2, and that's going to give me 32,324, and then I've got 30 times 11.8, and I'm going to use a calculator on this one just to kind of speed things up, because even though I'm not really in a hurry or anything, I don't want to take longer than I need to and bore my students to death. So that's going to be 354. Now I just have to add those all together. So 354 is already put in there for me, plus 324 plus 600, and it gave me 1,278, and our unit to measure is feet square. So I have for number 3, 1,278 feet square. I could also refer to it as square feet. Now, my numeric expression is this one right here. I used what I know about finding the area of a triangle, finding the area of a rectangle to get my answer. Also, I kind of made a model here with my net to make sure I wouldn't leave anything out. And here is my answer. This would be the surface area of the pyramid. So, boys and girls, what grade would I deserve if I were a random reporter for a group? 100. Yeah. Now, children, it wasn't a difficult problem. All it was a multi-step problem. Once I figured out which triangles were congruent, after I figured out the dimensions of the triangles of the base, then it was just a simple matter of writing out my numeric expression and then solving it or evaluating it. Okay, do I have any questions on this? Okay, I don't have any, so I guess I must have done one spectacular job demonstrating this. Good job for me. I appreciate the applause.